So, adding fractions to start with. Now, what I've written there and you've written down, you cannot add fractions that are a different size, and the size is shown by the denominator. So 1/6, 1/4, different sizes. Now, do you know what I mean by when I say size like that? Mm-hmm. So if you imagine cake, for instance. Now, of course, if why is 1/6 smaller than 1/4? Can you explain, Jane?
And there will be more.
Yeah, exactly. So if I've got a cake and I've got the same cake, if I chop the cake into 6 pieces or I chop it into 4 pieces, you'd rather have one of the bits of 4, right? So, and this is the thing. So when I say you can't add fractions with different denominators, it's not strictly true, because if I've got cakes, for instance, if I've got a cake that's chopped up into 6 pieces and I've got a cake that's chopped up into 4 pieces, and I take one of those 6 pieces and I take one of those 4 pieces, can I put the 2 pieces side by side and make a bigger bit of cake?
Yes.
I can. So I can actually do it. So, for instance, what it would look like, if I can just draw roughly. So let's say that was 1/4 of a piece of cake. Okay, and then that, for instance, was 1/6 of a piece of cake. I can stick them physically together if I have cake. So this is cake, just in case you didn't know. All right. The trouble is not putting them together and physically adding them. It's what do I call that? How much of a cake do I have now? And that's the problem. Right? You can actually, if you have the fraction, you can put them together, but it's what do I call it? So, if you were going to call that an amount of cake, what would you call it? So, if someone went to you, oh, actually, just rather than having 1/4 and 1/6 and putting them together, what would you like me to cut it into in the first place? What would you tell them? Okay?
Half?
So, you think it's a half?
No. Yeah.
You think it would be a third? And
Yeah,
you kind
third.
of look at my drawing.
Yes.
My drawing was really kind of
No,
rough
it's
and
a
ready.
third.
But the thing is, here's the problem. You need something to call it. So if the people went, right, you can have 1/4 and 1/6 of this cake in one box, but you say, oh, but I can't have it into 2 pieces. I need it in 1 piece because it will look silly or mess up. So they'll say, well, how much do you want then? And you need a way of explaining it. So do you think it might be a third?
Yeah, roughly.
That's just because that's why my drawing is awful. Let's do it mathematically. So what we've got to do is think, well, if I have 1/6 and I add 1/4, got to find out putting those together, what does it give me? You already know, Millie? What would you do?
When you do the 6 plus 4, yeah, no one has to know.
So you think it would be 2/10?
Oh, no.
You're right. It's not just adding the tops and adding the bottoms. It's not as simple as that. It would be nice, but it's not.
You would do 24 goes into 6 and 4. So 24 divided by 6 is 4. So 6 times 4. And 24 divided by 4 is 6. So 4 times 6. So the denominator would be 24. So now that's the same.
Okay, right. So here's the thing. Right, this is what Sophie's doing. What she's doing is finding equivalent fractions. So before we get our cake, we imagine, well, what happens if I chop it up into even smaller pieces? And then I can work out, well, how many pieces of the same size would I get out of all of this? So I've got to think, well, if I chop 1/6 into pieces and 1/4 into pieces that are all exactly the same size, then I can say to the shop, oh, I'll have that many of this size instead. And then they can just chop it as well. So we have to figure it now. So Sophie says, well, actually, 1/6, well, 6 goes to 24, and 4 also goes
Yeah.
to 24.
And now you can just add 1 plus
So,
1.
no.
Oh, so you would do,
What
would
would
you
the
do
1
the top
be?
6?
So how many 24s?
Oh, so that would be a 4?
So this is times 4.
4.
I have to do the same
Oh,
at the
yeah,
top.
yeah. So it would be 4?
Do you remember that from before, Jenny?
Yeah.
Did you catch that when you caught up? The
okay.
fraction is the same thing if you do the same to the top and the bottom.
So it will be 4 plus 6 is 10, so it would be 10 over 24.
Okay, so this one would be times 6 to make the 24, so this would be 6. So yes, it would be 10 out of the 24 pieces. Okay, now the thing is, just to say that is not the simplest, I could say. So that's chopping the cake really small. I don't need to chop it that small. So 1/6 plus a quarter could also be not split into 24, but
2 over...
Well, let's go from this point. How can I try and make it the pieces a bit bigger? Rather than having to cut 24, how can I make it slightly bigger? So Sophie went straight to 24. Do you understand why?
Yeah,
6 times 4. We can do this times 4 and this times... But I could do it differently. Is there any other common multiple? So what I'm looking for is the...
Yes.
Do you remember? The lowest
common multiple.
The LCM,
Oh.
of 4 and 6. So what is the lowest common multiple of 4 and 6?
12.
12. So actually, instead of 24, I can go to 12 and 12.
And it's not 2 because 2 is below 4.
So this was times 2. So it should be 2 over 12. This one is times
6.
3.
No, oh yeah, because it's 12, sorry.
So it's 3.
It's going to be 5.
So it'd be 5 over 12. Go on, Millie, what were you saying?
No, it's 8, because like 6 times 2 is 12.
Exactly.
But sorry.
Yeah, go on.
I also wanted to say when we got 10 over 24, there was also 5 over 12.
Yeah, we could also do a simplify here. Okay, so divide by 2, which still gives me 5 over 12. Same thing. Okay, but this here, right, this way is by using the lowest common multiple. Here, 24 is a common multiple, right? Multiple, but that means I have to simplify after. So if it's nice if I can get the lowest common multiple bit in there. Okay, makes sense. So let's have just a look at one more. So if I do 2/3 plus 4/9. So Sophie's very confident, so we're going to ask her to stay out of this one. See whether. Go on then, Jana. What would you do?
2 times 9.
So you're going for what as the common multiple, so the denominator. So we're looking for the lowest.
27.
So you think 27 is the lowest one? Well, I tell you what, it is common. So 27 and 27. So this one's times 9, and this one's times 3. So we have to do that. That one becomes
12.
And this one becomes.
18.
So therefore, the answer will be. So Sophie, chill out. Let the other ones. So it'd be 30 out of 27. Although, is that the lowest common multiple?
No.
What's the lowest common multiple then, Sophie?
9.
9. So actually, 9 does not need to change. The 3, however, can go to 9, which is times by 3.
So 3 times 2 is 6.
So that one's still 4 over 9.
Yeah, because,
But this one is
6,
6, which makes
10 over 9.
10 over 9.
Which is an irregular fraction.
No. It's called an improper fraction
Sorry.
or top-heavy fraction is what we've got. Now, just to see whether you remember from last year, do you know how to turn that into a mixed number? Millie, do you know how to?
Mm.
Do you know how to, Jonah? So mixed means we have a whole part. Because obviously if it's 10 out of 9, that makes more than a whole cake, doesn't it? If you cut a cake into 9 pieces, but then you have 10 pieces, you've got a whole cake. So explain, Sophie.
So you would draw a whole cake, and then another cake, but just one of those pieces.
Okay, so we reckon, so we've got however many pieces, so there's 9 pieces there.
So all of
and
them.
this is one extra piece.
Mm-hmm.
So actually 10, oh, that was a bit unfortunate. 10, sometimes it works. Right, so 10 is actually, 10 ninths is the same as 9 ninths and 1 ninth.
Yeah.
Now 9 ninths is the same as having 1 whole one. So I can say that it's 1 and 1 ninth left over, and that's the mixed number. Make sense?
Yes.
Yeah. Alright, okay, so if we have a look in your book, we're all the way up to unit 4 now. I would like you, so probably quite easy, we'll have a look at page 66, question 2. Okay, so you're going to look at page 66, question 2. Right, let's go through some answers then. So we've got A, 1/2 plus 1/3. We would change that to, Sophie?
5, 6. Well, the lowest common multiple is 6.
Okay, so it's
2 times. So 2 times 3 is 6.
So it's 3 over 6 plus
2
over 6.
which
So
is
the
5,
answer
6.
is 5 over 6. Okay. B, so we've got 1 over 5 plus 1 over 4. So Millie?
It would be
Over 20.
Yeah.
And then it's
5 times, which is 4.
4 and
5, which is 9.
9 over 20. Yeah. C, Jaina, so we've got 1 over 7 plus 1 over 3. The common denominator is? 21. Okay, so that would be what over 21?
3 over 21 and 7.
So the answer is? 10 over 21. Okay, and then D. Sophie?
The lowest common multiple is 20.
Not there yet. 2/5 plus 3/4. The lowest is 20. Yeah.
So 5 times 4 is 20. So 2.
So yeah.
Yeah.
Yeah, times 4, so that
Yeah.
makes
8.
8 over 20.
And 5 times 4 is 20. So 5 times 2 is 15.
Yeah, so 15.
And 15 plus 8 is 23 over 20.
20.
Which means it would be 1 whole cake and 3 pieces. Yeah.
3 out of 20. So 1 and 3 20. Okay. So that's in the mixed fraction form. E
is 1 over 7.
1 over 7 plus 3 over 8. Go on, Emily.
It would be 56 because 7 times 8 and 1 times.
So times 8 would make
8.
So times 7.
21.
21.
Which would make 13. No.
It would make
29.
29. Good. 29 out of 56.
Can you make it any simpler?
It shouldn't be able to if that was the lowest common multiple. So 29 is a prime number now. You find it?
Yeah.
Yeah. So it can't divide by anything anyway. Okay. Right. Just before we go to lunch now. No, Sophie can't wait for lunch. Jaina, 1 over 6 plus 2 over 3. Lowest common multiple.
18. Lowest common
That is a
multiple
common
6.
multiple, but it's not the lowest common multiple.
6.
Lowest common would be a 6. It's 1 over 6 and 4 over 6, because you just multiply this one by 2. Now, if you had done 18, what would your answer have been? So it would be 15 over 18, which simplifies 2. So you'd have been able to divide both by 3 and have 5 over 6. Or we'd have just done it to the lowest and had 5 over 6 anyway. Not yet, because we're going to go to lunch. Well done, guys.